pretty old story, I have to say, because I wonder if you wonder why we have a structural engineer to talk to a bunch of architects. I don't know, not all of them, or rather you are architects. So actually, in the early, uh, late 90s, I think, early 90s, I was starting to teach and at Peking University. I had a whole series of lectures by Japanese architects. So as you can imagine, in those days, I was younger and very naive. So I would ask all the architects from Japan the same question. I don't remember all the answers, but I remember at least two. The first person um, answer my question was Shigeru Ban. So I asked him, what's the most important thing in architectural design? So that was what I was concerned with. And he thought about it and he said, structure. So I was a little surprised. So anyway, and then I went on. And then Toyo Ito came along. Of course, I asked the same question. What is the most important thing in architecture, rather architecture design? Ito answered before I finished my question. He said, structure. So ever since I realized there's something about structure architects really should know. And then luckily, of course, not too much later from that point, and Guy and I, we met. There are two ways to introduce Guy. One is the easy way, so I'll do it in case you don't know Guy. So he's one of the most prominent structural engineers from the US, and he's a professor of at Princeton for a very long time. Now I like to try the harder way. So for that, I need to use the but more than syntax. That's the only way I guess I could do it. So Guy is, as I said, a renowned structural engineer, but more than that. As an engineer, because he actually would really work side by side together with the architect on the design. He's one of the very few true partner or comrade of the architects. And he also would solve from time to time problems in a very surprising manners. So the one I heard, so Guy, you may correct me because I heard not from you, it was a rumor from somewhere. So Sejima was making the glass museum in Toledo, and then she wanted to stabilize the top of that building, and she couldn't. And Guy was working with her on that project and really advised, or rather, just gave her the solution for that problem, which was just let the roof move. Is that true or not? So, okay, which means that's true. Yeah. So anyway, of course, there are other stories. Guy worked with a lot of really innovative architects, and of course, he is part of the innovation. And then he's an educator, but more than just an educator. He does not only teach courses on structural design, he imagines a sea change for the structural engineering education. And at this very moment, he's really thinking of a possibility that for China at least, the education of design and technology could be totally integrated. And that's why actually he's here. He's not here alone. He didn't come here alone, rather. He brought many colleagues, some deans and professors, of course, from several Chinese universities, including Tongji University. I think the new dean of Tongji and some other professors, they just landed. They're on their way here. Uh, so they're gonna be here. Let's see, probably in 15 minutes. And then we have also colleagues from Tianjin University as well as Southeast University. In case you don't know, that's my alma mater. So anyway, and for the next 2 days, Guy and all these colleagues coming from afar would have a workshop in the classroom on the ground floor to discuss what I just proposed is how in China we could develop a new approach to improve upon the design education so that technology and design, or rather architecture and the structure, can be much fully integrated. And you will see the discussions of this small group of people, which are going to be locked in the classroom. Not really, but they can. And then you can watch that, or you can watch the huge LED screen to see the real-time broadcasting. So with that note, I would like to invite Guy to come up to the podium. Thank you.
I use this. Okay. Thank you for that wonderful introduction. I thought I would start, maybe given the introduction, with a story about Toyo Ito that relates to what I'm going to present. And this may be apocryphal, but this is a story that I heard, that when he went to school at the University of Tokyo at Todai, he thought that he was going to study engineering. And if you're familiar with the University of Tokyo Architecture School, the architects and the engineers are in the same building, one of the older buildings, at least they were. At the same time, Mutsuro Sasaki, who is one of the most eminent, if not the most eminent, practicing engineer now in Japan, was also going to the University of Tokyo thinking that he would become an architect. On the way through their education, one switched sides and the other also switched sides. And so somewhere along the way, they must have crossed paths. I don't think they knew each other in the university, but eventually they collaborated. And in fact, when I worked on the Toledo Glass Pavilion with Sana, I was there because Sasaki had asked me to collaborate with him, who is the engineer that they always work with on that pavilion. So there are cultures like that where there is a common foundation of education and of culture that is essential, I think, for the kinds of collaboration that you can see has happened over the years. For example, in Japan, not just Sasaki, but people before that. I have a book, actually, I think I'll show you the cover at some point, which traces that history, if you're interested in that, because what happens is that you have a figure like Tange after World War II, who has in his office associates, Maki, Isozaki, who then go on with their own practice. And in parallel to that, you have the engineers that Tange worked with, for example, on the Yoyogi Stadium, Kawaguchi and Tsuboi, whose proteges then, including people like Sasaki, end up working with each succeeding generation. So there is this knitted fabric of culture between these two practices, which I think is a very important thing that we can learn from. So I'm going to talk a lot today about collaboration and collaboration as a generalized practice that I think we see some of. I've been lucky enough to participate in, but I don't believe is as mature in our profession as it could be. And so I want to talk a little bit about what happens in film as an analogy and maybe an example of how we might think about practice, how we might think about recognizing creative contributions, and how we might think about education. So some of these ideas that you'll see have to do with an analysis or interpretation of what I see happening in the movies. Um, I've got quotes. I'm not going to read them to you, but that start each of these sections that tries to set the tone. So you may have seen Steven Spielberg's movie Lincoln, which has as Lincoln Daniel Day-Lewis, who is an extraordinary actor. Here you see him in one of those scenes. In that movie, you will notice, particularly in this photo, the intense cinematographic interpretation that is in play, right? You're in a dark room, the light is coming through the window. It has him in profile. He's carefully positioned in that place. It's a combination of creative decisions by, of course, the director, but also inevitably by the actor and the other actors, as I like to call them, that are participating in the production of the movie, in this case, especially the lighting designer and the cinematographer. Those of us who are obsessed with film, and I'm obsessed with film, will know the names of cinematographers, will know the names of those people that contribute to these moments in film. And if we don't, and we watch the Oscars, we'll be told who they are because each of them will get an Oscar in these situations. The theme of the movie about Lincoln is about the team of rivals. It's the title of a book that was written about the relationship that Lincoln had with his cabinet. He purposefully brought into the cabinet, because he knew he was going to end up at war, people who opposed his ideas and opposed his policies, because he wanted to have in that room those opposing views that he could then argue against. And you see that acting out very much so in the movie, not only with his cabinet, but with his collaborators in Congress. That notion of the team of rivals, and you see them here sitting around the table, is essential to understanding the success of Lincoln. And I think also the success of Spielberg. If you've seen, and I'm sure you've seen many of Spielberg's movies, there's a consistency with which he chooses the actors. Tom Hanks shows up a lot. Mark Rylance shows up a lot. There's also a consistency with the editors that he works with the cinematographers, with the people that compose the music. There's not always the same look in his movies, but there is an attention to those details that is contributed by the team of rivals, if you like, the team of creative talent that come together to make these movies. So the Lincoln movie, in a sense, is both an example of his creative work as a director and of the creative work of the actors. He is, in film jargon, the auteur, the author, but it's also an evidence of what it takes to create really great works, as I think this movie is a good example. And there you saw at the bottom there, the book by Doris Goodwin called Team of Rivals, on which that movie was based. When Obama was elected president in the US, he very much wanted to create that kind of atmosphere in his government of bringing in the team of rivals. That's why he brought Hillary Clinton in as the Secretary of State, because he was quite aware of that book and quite aware of that interpretation of course, the greatest president that the U.S. has had, Abraham Lincoln. So I've been very interested in these questions for a long time, probably, I mean, inevitably because of what I do, but also I think because of what it means in terms of the education of architects and engineers. A couple of years ago, I collaborated with Seng Kwan, who's a professor at Harvard and also at Tokyo, on this magazine edition of A+U about the collaboration between between artists and engineers, and many examples, including Picasso's sculpture in Chicago, where when you look at the history, you start seeing a different kind of interaction, but an interaction that is also quite productive and is illustrative as well. And I'll show you at the end a work that I did with an artist more recently. These are some of the books, and the book that I wanted to mention to you that I've helped put together, Structured Lineages, is actually influenced a lot by Seng Kwan. And it has to do, as I was describing, with this historical parallel lineage of architecture and engineering that you can find in Japan, especially in the post-war period, probably having something to do with the fact of earthquakes and the necessity to pay attention to the structure, but it's obviously at this point deeply embedded in that culture. And so I asked a group of engineers from around the world, people in my generation from Germany, Mike Schleich, Mark Mimram from France, others, Bill Baker from the United States, to talk about the work of the engineers in Japan. So trying to create this cross-cultural dialogue and representation of this perspective on that culture. The book on the left is a series of lectures that I organized at MoMA as well, of an older generation of engineers, trying to bring them into the museum, trying to bring them into the conversation in both ways. And then the last book is an exhibition that I did with Terry Riley at MoMA not long after 9/11 to try to think about the future of tall buildings at a moment where obviously we had gone through a terrible crisis. On the bottom right, you'll see a drawing there, which I'll come back to in a second, which is a drawing of the World Trade Center towers that had been destroyed on 9/11. So these are some of the buildings that were shown in the exhibition. A big part of the exhibition that I felt was very important was to show the buildings in section. And if you think about the CCTV tower, part of the magic of that idea and the inevitable evolution of the idea was the ambition of what it was going to do in section, not only as an object, a beautiful sculptural object in space, but also as a kind of inventive spatial idea about what would happen in terms of circulation and what happened in terms of section. Obviously, not all that played out as the architect had wished, but it was an ambition worthy of being represented as we did here. Okay, this is it's a great poem by an American poet, William Carlos Williams, who was also a doctor, right? So there's also this kind of multiplicity of roles that people can play in life. You don't have to be just one thing. You can be going back and forth. You can be a writer and an architect, a critic, and an architect, and so on. So I want to talk a little bit about the World Trade Center. This is a photograph that was taken shortly after the building was completed by the engineer Leslie Robertson. And Robertson worked with Yamasaki on this building and did something very inventive, which nobody knew about until we did a drawing that I'm about to show you. So you may be familiar with this structure. I hope you are. It was quite an abstract work of architecture because each of the vertical members and each of the horizontal members that make up this cage, that's a kind of stiff tube that resists the wind loads, each of this is the same outer dimension from top to bottom. So there's no recognition of the fact that this is a heavy building coming down to the ground, resisting wind that is quite strong, and would normally, I suppose, be thought of as something that would get thicker at the base. Instead, it's all the same throughout, top to bottom. So there's this very specific decision to create this kind of abstraction of a building that also has a specific role in resisting the wind loads. Given that, and I don't know whether the idea that all the members would be the same came from Yamasaki or Les Robertson, but given that was a premise that they may have invented together, what Robertson did was to manipulate the kind of steel that each part of that building would be made from. So he picked 14 different types of steel, ranging in strength from very strong to normal, if you like, and located them, as you see here, color-coded. The red is for the high-strength steel, the blue is for the lower strength steel, and distributed them in a way, these are unfolded elevations, by the way, distributed in a way that achieved the goals that he had for the behavior of the structure. And what he was trying to do was overcome an effect that you get in these kinds of box sections where the forces try to stay near the corners. So the purpose of a box section like this is that you're making it a complete section where the front and the back are going to contribute to the stiffness of the building as flanges, right? But the problem is that the forces that are going into the flange from the sides doesn't always get into the middle of each of the faces of the front and back face. So the way he wanted to deal with that was to make the corners softer by using a high-strength steel that would allow you then to reduce the thickness of the plate, because that is one thing that varied, and soften them so the force would move away. So counterintuitively, he was making things stronger so they would be softer, so they would take less force. So it's a very kind of subtle approach to the engineering, which is manifest in this. Now, he was responding to what? He was responding to the variation in wind load coming off the water side or coming off the city side. He was responding to the fact that you had two towers that shielded each other from the wind. So what you're getting here is his choice, but also a representation of the results in the wind tunnel of the effect of this particular environment with a particular distribution of wind forces at different times of the year and the relationship of the towers to the city. So we drew this all in this drawing, which was exhibited in that MoMA show, as a manifestation of this amazing creative act that had never really been understood or seen before. So here was somebody who was making something extraordinarily special that no one could see. Here you can see how these members are all the same. It was all prefabricated. Everything was really made from scratch. They were trying to channel the idea of the Apollo program into architecture. They were trying to make something that had the same kind of ambition and technical prowess as that, the lightest possible building they could make. So that's one model where there's a creative act that actually erases itself. Another kind of model is the Statue of Liberty, where you have three very separate authors operating in parallel. You have Eiffel, who did the structure inside that you see there all the way on the right, and you have Bartholdi, who designed the sculpture that you see on the left. This is when it was being mocked up in Paris before it was disassembled and shipped over. Everything was prefabricated in Paris in these shops. The skin is a thin copper that was pushed into its shape on wooden molds that they've installed in the shop. Very complex, beautiful folds in that skin. And then the structure inside, sorry, the structure inside you see there on the right is a kind of pillar, like a core of a building with arms sticking out that then hold the sheets of that skin like leaves on a tree. So the sheets are independent from one another, floating relative to each other, held by these branches of this kind of tree-like structure. Here again, a very different effect on the outside than what you learn as you get to know what's happening on the inside as well. So what one way, and this is maybe a little bit more obscure, but one way for me to think about structure in its role in society, maybe responding to Shigeru Ban and Ito, you know, what do they mean when they say structure, right? They don't necessarily mean something instrumental. It's not just the structure that is there to hold up whatever form they come up with. It's something different. And I think one way to understand how it's something different is to think about what happens when you're faced with a ruin. So after 9/11, I helped organize a group of structural engineers that went out about 3 days after so 9/11 was on a Tuesday. We were on site working on Friday, helping the contractors move things around safely. So basically keeping an eye on what they were doing. Everybody was very traumatized. Everybody was working really hard. It was a situation where people could easily make mistakes and get hurt. So we organized into groups, and then I also organized teams to go out into the neighborhood and map the damage on all the buildings, about 400 buildings in the neighborhood that had been evacuated, so that people could come back and live in the buildings that were safe. And we used some techniques that had been developed for post-earthquake damage evaluation for that. But one of the things that was immediately discussed is, what do you do with all this? And unfortunately, the American impulse in a situation like this is to wipe everything off and hide it somewhere. What could have been the case is that we might have kept what remained. Let me go one head up. I'll come back to those. We could have kept what was there and used that as the monument. That's the structure. And the structure was something that played a significant role. I mean, people are focused on the fact that the buildings collapsed, but it's true that the buildings also stood up for quite a long time, for almost an hour before they collapsed, which meant that people who were below the fire, the people above the fire could not get out and died. The people below the fire were able to get out. And that's actually one of the reasons why Rem came up with the idea of the loop, was a reaction to the lesson that he and everybody else learned about 9/11. This could have been the thing that we were looking at in the future as the monument. And the reason I show this slide is I worked on this was the portion of the old slurry wall that became a kind of symbol for people. I think Danny Libeskind was in particular quite attached to this slurry wall. And so I was given the job of figuring out a way to hold the slurry wall without putting any structure in front of it so you could actually see the thing. And this image is showing you that portion, as you see there in the middle of the old slurry wall that's being held from behind, and is now part of the museum there. So that's a ruin. That was part of the structure that had some sort of meaning for people as a symbol of resilience, as a structure, which before that time didn't really have anything more than an instrumental role in the building. So things get transformed in that way. Think of the Parthenon, right? It's a ruin, but we're attached to it as it is. We don't want to go back in there and paint it back with the colors that it had before. We don't want to go back and add a roof and do everything else. There is some restoration going on, but we see this as a ruin, and it is a structure. It's a peculiar structure because it's made to work like a wooden structure, but it's an extraordinary influence on at least on Western architecture. There are other examples here in Berlin, the church that was bombed during World War II and was kept, and they built a new church around it. So how we react to tragedy, what's our relationship to ruins that are the manifestation of those tragedies, is a relationship to structure, if you like. And so I think to some extent that may inform what Shigeru Ban and Toyo Ito are saying. There's something for them about the structure that has a deep cultural significance, and I think it's represented by these situations. Now, the Parthenon is in some ways our idea of a monument, of cultural heritage. We preserve the Parthenon. The Parthenon is made of stone. We preserve those ruins that are made of a material that has a sense of permanence. There's another way of thinking about heritage, which we see with the Ise Shrine in Japan. This is a photograph that was taken when both shrines were there. This was back in 2013. You got to go in 2033 when it happens again. It only happens every 20 years. And that is a time when you can go see the two side by side as well. I'm fascinated with this for many reasons. Um, one of which is, in this case, what is monumental are the practices associated with the rituals, with the craft, with all the things that have been sustained for 1,200 years. It's going on its 63rd repetition of that reconstruction. And there are carpenters, metal workers, all the people that do the thatch, and I'll come back to thatch in a little bit, um, that are trained through multiple generations of rebuilding so that you start out at a 10-year-old or a 12-year-old or a 15-year-old, and you may end up as the master at the age of 95. So that is a different kind of relationship to structure, to monumentality, to craft, all of which I think play into the reaction that you were describing from these folks. And here you see the old and the new, lots of reasons why it's rebuilt, the relationship to the deity, lots of not so nice reasons why it was such a significant part of Japanese culture, because it represents the fact that the emperor was a deity. It's a complex thing like any other work of architecture, but it's worth understanding and studying. So that's, oh, I keep doing this. Sorry about that. I'll lean on this. So that's one way to think about structure and one way to think about the way it plays a role in our culture. And that comes back to this question of what are these forms of collaboration that are represented in these kinds of situations that we can study and learn from. So with film, you may be aware that there was this moment in the 1950s where a group of French directors developed this auteur theory based on people like Hitchcock, or Howard Hawks, who were American filmmakers who they saw as having a particular style that they repeated throughout their films. You go to Hitchcock movies, they're all different, but they're all also the same. They all have a consistency about them that you're going for, that has the impact that it has on you, and has many features. The cinematography, if you are familiar with the movie Vertigo, there's a moment near the end where Jimmy Stewart is climbing up this tower, and he, of course, has vertigo. And in order to represent that, the cinematographer came up with this idea of having the camera on rails. And as the camera is moving up the inside of this tower, it's zooming down. So some genius came up with this idea that the best way to make the audience feel vertigo is to do this weird special effect. That kind of inventiveness. I was reading an essay the other day about Sergio Leone, the film director who did A Fistful of Dollars. Anybody familiar with Clint Eastwood and A Fistful of Dollars? Do you know the way the music goes? Right? So when Ennio Morricone was hired to do the music, Sergio Leone wanted him to just do what Howard Hawks did and use the same music that Howard Hawks, the American director of Westerns, used in one of his movies. Of course, Morricone said, no way. You hired me. I'm going to make the music. There's a longer story around this, but he turned around Sergio Leone's idea and made a new kind of music for that movie, which nobody who's ever seen this movie, and you all have to go out and see, Fistful of Dollars, is that what it's called? Yeah? Fistful of Dollars? I think so. With Clint Eastwood. Hmm? It's the one at the end where there's that circle and the three guys have Clint Eastwood. Another example. Clint Eastwood starts out as a spaghetti Western actor, ends up as a film director. People switch roles and so on. Anyway, back to film, or back to this film. The auteurs, of which François Truffaut was one of them, were also interested in telling the story of their lives. So Truffaut had a very interesting life. He was an orphan. He bounced around throughout his childhood, had all kinds of adventures. But of course, if he wanted to make the movie about his life, he needed an actor. So he couldn't be, I mean, he could have been like Woody Allen, but he wasn't both the actor and the director. So he had to find this guy. Um, why am I blanking? Jean-Pierre Léaud to play the character Antoine Doinel, who is representing the director. There's 5 films over a period of, I think, 15 or 20 years that are made about the story that is being told through these different 5 films of his love affairs and so on. But he is both the author and yet he's displacing his person into this character. Then later, Spielberg, back to Spielberg, Spielberg brings Truffaut onto the set of First Encounters of the Third Kind, the one about the aliens, great movie, as the scientist. And he's playing with your understanding that this is Truffaut, this Frenchman, he's a French film director, very famous, appear, and yet he appears in an actor in this role, and he's the specialist who knows everything about the aliens that have just arrived. So directors play with these perceptions. They play with your understanding of where these actors have been and so on as they and of course also with the special effects. And Truffaut interviewed his hero. There's a whole series of conversations between Truffaut and Hitchcock which are really interesting to read, where they're talking about their craft. They're talking about what it means to do what they did, which Truffaut interprets as authorship, but which is really a much more complex example than just that. So back to architecture. I teach this course, and my ambition is to turn it into a book called Construction and Interpretation, which is trying to look at examples of notable works of architecture where there is a complex interaction between the actors that are participating in it. Usually you can tell who the author is, the architect, like the film director who is in charge and making the key decisions. But sometimes it's more complicated than that. And sometimes that complication makes it a more interesting work of architecture. So this is the Phillips Pavilion of Le Corbusier, which he worked on with Sanik Xenakis, who was an architect who eventually turned into a composer. Corb's idea was that this pavilion was like a stomach. You would go in one end, you would digest the experience, and you'd come out the other end. So that was his diagram of l'estomac. What Xenakis was charged with doing was turning that into a three-dimensional form based on these sketches that were done by Corb. Corb was very busy with Chandigarth, and so he wasn't there a lot. And so Xenakis ended up in charge of this process. Building this thing was complicated because it wasn't really a shell. So they had to come up with a system of prefabricated panels that they then erected, these concrete panels cast on sand, something that Sana did, that Nishizawa did recently with Sasaki as well. So cast on sand to make the panels that make up this thing. It's a situation of complex authorship because Korb was absent most of the time. Xenakis was making all the decisions, but then they fought over it quite strongly and fell out after a while as well. But the end result, I think, is a really interesting work of architecture. And if you want to study it, there's a wonderful book by Mark Tribe that goes into detail. You can also find the videos online of what was happening inside. It was a full experience. Movies, music, etc. It was a complete happening inside. Another example is the collaboration between Pierluigi Nervi and Marcel Breuer on UNESCO. The team of architects that was put together to make this building was established by a larger group of architects who were put in charge by the UN of deciding how to make this campus plan and then the buildings inside this. Here you see some of them: Korb, Gropius, Morkelius, Ernesto Rogers, Saarinen, Niemeyer. So they were all there, some of the same people that were involved in the UN in New York, both at the UN in New York and at UNESCO. I think their major goal was to keep the job from going to Corb. Corb, of course, wanted to do it all, and their role, particularly in this case, Gropius's role, was to try to maintain this as more of a group project. And eventually, they selected these three architects: Derfus from France, Nervi, the older man, and Marcel Breuer, who was, of course, a protege of Gropius. What you see when you cut a section through the building is this very characteristic structure by Nervi. A little bit like with the Statue of Liberty, you have a structure of great elegance and sophistication that is inserted inside the building that you see here, the plan of which was decided and developed by the group that you see in this picture. So the basic organization of the site, the Y-shaped plan, the orientation to the city, all those things were decided by this committee who worked quite collaboratively in making those decisions. And then they assigned that project, having established the overall plan, to this group of architects. And they collaborated in a way that still maintained a certain distinct voice for each of their contributions. Breuer went on really having absorbed the vocabulary that he learned working with Nervi, and that essentially became his practice. These muscular, brutalist buildings that he did, the structure of which were not always as clear as they might have been, were very much his effort at internalizing what he had learned from Nervi. There's a wonderful book that Barry Bergdahl put together of essays about Breuer's career as well. And I have an essay in there trying to argue and explain about the structure. There are other buildings that have the same sort of characteristics, but also actually have an even more significant role as symbols of a nation. This was a building, the Hall of Nations, built shortly after India got its independence. Nehru commissioned it, and it was done by Raj Rawal and the great Indian engineer Mahendra Raj, who had worked on Chandigarh with Corb. It was since destroyed. So sometimes a structure, and this is a very unusual structure because it's a big space frame made out of concrete, which is not kind of the normal thing. So that in itself was an effort at producing a sense of modernity, a sense of the rise of a new nation, which is, of course, why in the current regime it was unceremoniously destroyed because of what it represented. So sometimes these structures have an important and significant role as national symbols. These here, the Olympic roof in Munich for the 1972 Olympics, again, a complex situation between a lot of different actors. Friado, of course, but the architects that actually stole his ideas and won the competition. And then the government said, no, you have to work with Friado because it's his ideas that you're using. Great engineers, Jörg Schleich were involved, Heinz Isler. A combination, again, of different actors coming together and producing, I think, in the end, a remarkable structure that at the time was meant, and I think did represent the notion of a light democratic spirit that Germany was trying to present to the world, even in 1972, not long after World War II. So structure plays a role. Here again with the Sydney Opera House, very complicated relationship between Ove Arup and Jorn Utzon. I've spent a lot of time in the archive thinking and reading about their relationship. There's lots of confusion about where different ideas came from. But in the end, Utzon he quit, but essentially was fired. And then the team had to execute his project after he left. And if you study the project and you go visit, I think it's a marvel of how well they had internalized the spirit and the concept, the glass walls, the interiors, all these featured a very true representation of an idea after the author had left the building. So these are great examples, I think, of how great works come about through these kinds of interactions, which in some ways are similar to what you read about and you can hear about in film, Orson Welles and other examples. This is the Mannheim Garden Festival Hall outside of Mannheim in Germany, another Frei Otto project, but with a completely different team, Ted Happold and others, Ove Arup, etc. Beautiful, very rational structure as well. And I'll show you a picture in a minute of how it was built. Pompidou Center, two architects collaborating together with an engineer, the guy all the way in the back in the lumberjack, that's Peter Rice. Very creative relationship between all of them throughout all their lives. So I think it's really useful and important to study these kinds of projects because they obviously, whether you like them from an architectural point of view or not, they have a cultural impact. And they have an impact because of their culture, because of the way they come about. And so their histories are really useful as a lesson for all of us in how we can work together to get certain things done. So I have 7 sections. We're on number 5. This is a really good, so, John Cage was a great musician and composer, whereas Cunningham was a choreographer and a dancer. They were also partners in life. They worked together a lot. But again, like with the Statue of Liberty, like with Nervi and Breuer, they did their own thing and somehow it came together. And in Mercer's case, channeling sort of the spirit of Marcel Duchamp, he saw that separate track colliding as the thing that made for the magic of the performances they did together. And I was religiously attending all the performances as best I could wherever I happened to live because I found it so energizing to see that. The production of buildings like this is Mannheim, the models that people make in the process are a kind of performance. We look back on the photographs and we're delighted by the energy that we see in these kinds of efforts. The construction, this is Mannheim again, made out of these thin sheets of wood, the way the whole thing was laid out flat and then lifted up like a tent and then stood there, even though it's so thin because of the shell action that is going on and that was so creatively produced by the team that brought it all together. This is really worth a visit if you're ever in Germany. And then the magic that's hidden. So the pyramid in the Louvre it was not easy for Impey to convince the French, the Parisians, that he could stick this in the middle of the courtyard of the Louvre. And so what he had to do to convince everybody that it was going to be all right was build this little sketch model that you see there on the right and take a photograph, which was published in the newspapers, which edits out the crane that's holding up the strings. So, there is Pei explaining to the French that it is not going to even be there. It will disappear. And the magic of making it disappear produced this internal ziggurat that you see there, which actually Peter Rice had a strong hand in figuring out, that could hold this cage of strings, this highly tensile structure in place while it was all being strung like a big musical instrument. So the magic that has to take place in order for things to happen, the performance that is a result of that, I think, is a source of joy. It's something that we can plan as well and turn into a part of our projects. This is a building I did in Rome with Richard Meyer. I worked with him on the competition. He had this really beautiful idea of these shells that are nested into each other. After we won the competition, the immediate reaction was, let's just build them out of steel and clad them with metal panels. I argued, that instead, being in Rome, in the tradition of the Romans and the tradition of Nervi, we should build it out of these large blocks of concrete that could be prefabricated and placed. There you see one there. The result of that was that the contractor came up with this giant gantry, La Macchina, that was swinging back and forth for 2 years, installing each one of these panels, building it block by block in a very systematic way, but also a way that produced this performance for all the kids that were growing up in the apartment buildings on either side. The building that Anderson Lee and I worked on together with Stephen Hall at MIT, Stephen had this idea that this was like a sponge. And so what we came up with as a result was a structure made out of these panels of precast concrete that were fabricated in Canada that fit together like a Lego system, were glued together, as you'll see in a second, with the concrete of the slabs, and had a pattern that had a lot to do with the way the forces were flowing. So as in the World Trade Center, the conceit was that all the members were the same. So the dimension of all the members is the same throughout this to create this kind of abstract effect. If you have to reinforce some portion of it in order to span or to deal with a cantilever, we would fill in the squares in those key areas to make that happen. So you end up with this random pattern of these as well. This is how they built it, pouring the concrete in between each stack of slabs. And then in the end, Stephen wanted to have a color pattern. And so we took the drawing that the site engineer had used in order to make sure that the steel was all in the right place, because there were different size steel in the different horizontals and verticals. We took her drawing and used that to paint the color. So if you remember what I showed you about the World Trade Center, this was kind of an homage to Les Robertson as well. Very different effect here with the Nelson Atkins Museum. These are a series of glass prisms. And what, actually, I don't show that. What I did with that was put all the structure in a spine down the middle and then cantilevering everything from the spine so that the structure in the glass would be tiny. So that's so that you really see the abstraction of this of these prisms. This was the parking structure in front, and we made these custom wave tees that produce the effect in the space of this sort of continuous corrugated effect. And then another version here. And I think in the case of this, it's the degree of difficulty that goes into sometimes producing something that is unique, that's not off the shelf, that is trying to achieve a certain spatial effect and is worth the effort in doing so. Similarly, in Houston, this building that we did more recently is made out of these prefabricated blocks of concrete that are stacked up and that are the structure of the building here. You see that. So this is an art school, and it has a certain toughness as a result. So this is a quote that I love, the one by Longfellow that Wittgenstein uses a lot. The idea, again, as we saw with the World Trade Center, that sometimes the creative act is hidden, that sometimes what an actor will do or what a cinematographer will do or what an engineer might do in a building is an act of creative craft that nobody will necessarily notice, but that is embedded in some ways in the spirit of that project, which is, I think, the thing that Wittgenstein was so taken with. So attention to detail. This is a building, an addition to the Kimball of Louis Kahn and Commandant, which was, of course, a very difficult project to take on, that Renzo Piano finally was the architect who was able to come up with an approach. He did so by really reflecting the geometry, the partie of Kahn, the idea of the three spaces of 100-foot, 30-meter length with gaps in between. So very humble, if you like, relationship to the precursor across the way, a certain distance from that. And the structure that we developed in relationship to that was based on using wood as the right counterpart to the concrete of Louis Kahn. We also have concrete, beautiful concrete that was supervised by a great concrete fabricator from Venice. And then these glulam beams that we designed, which are supporting the roof. Here's one of them, and this is the result of that. A key choice in this project was to let the structure be shown. If you're familiar with Renzo Piano's work, after the Menil building that he did with Peter Rice in Houston, most of the museums that he did are suppressing the structure behind a series of layers of scrims and louvers that filter the light. So it's more like the lens of a camera creating these series of layers that produce the light effect in the galleries. We still have that in the galleries here, though the structure does appear, but we were able to see the structure in this case and have it play a role. And the details were really important. Because we don't have any kind of structure in the horizontal plane in the roof, because it's all glass, we needed to brace these thin beams against buckling sideways. And so we came up with a system of these H-like shapes, dog bones we call them, that were holding the beams from twisting, and used pairs of beams so that they would help each other out as well. So all that detailing, all those little white lines that you see are part of that system, and they have a kind of precision and a highlight to them that is instrumental in the function of that roof. Similarly, with Tom Pfeiffer, the museum we did in Corning also has an open glass roof that lets the light in. And in this case, the idea was, and this is the floor of that, which is actually supported from above by the concrete walls that make up the galleries. Here you see them under construction. And then on top of that are these very thin precast concrete rafters. They're about, 3.5 inches wide, and they span up to about 18 meters. So very thin, again, spanning great distances and creating the light effect, but also creating this ambiguity about the kind of structure that might or might not be supporting the roof. I think the precaster, who were the same people who did the MIT building, were actually confused until the very end whether they were making structure or light louvers. And for the nerds in the room, it's complicated to do the analysis of the buckling of a thin beam that is, up to 15, 18 meters long and very thin, because it wants to buckle sideways, but because it's concrete and we didn't want to tension it because it would make things worse from a buckling point of view, we had to come up with this approach of analyzing a cracked beam and understanding whether or not it was susceptible to lateral torsional buckling. And then the way they sit on the walls varies because of the relative geometry of these lines and the walls. And so this is a kind of early proto-parametric approach to that. Creates a kind of abstraction in the space, but it's an abstraction that is produced by the structure. And I think we're coming close to the end here. This is a building we did in Houston with Johnson Mark Lee, who's from here. Many of you are probably familiar with him. And their design was very much a kind of folded paper, almost origami-like geometry. And so I proposed that the canopies that are outside the building that produce these two courtyards be made out of folded sheets of steel. What I think nobody quite understood, or they didn't quite understand as we were doing this, was that you would sense the materiality of the steel. I think part of the effect that they were looking for is this sort of abstraction that you get from these images where you have these very flat matte surfaces of white and surfaces of glass, creating this abstract folded paper kind of object. And you get that feeling very much when you go inside. And when you see the light shining directly on our steel walls, you also get that. But then when you start to get raking light, you start to see the materiality. So I think that double nature of the steel in the end contributed something, but it was definitely a choice. The other thing that's quite beautiful there, if you get a chance to visit, are these walls which are made of hinoki wood, which is the same wood that they use for the Ise Shrine, called Port Orford cedar in the U.S. And it was made by a fabricator in Northwest U.S. who blasted the wood with glass beads to create a very beautiful rough texture. That's it under construction. Okay, this is hot off the press. So this was in the newspaper 2 days ago. So I teach a studio with Paul Lewis. We've been teaching together for a long time. And for a long time, we were doing studios related to flooding and the design of communities and buildings in areas that are susceptible to typhoons, and mostly working, though, in the US and parts of Europe. But Paul has shifted his interest to working with biogenic materials. And so this is a project that we did recently of building a little pavilion out of straw and thatch. So maybe related, if you like, with the Ise Shrine idea, but it's an experiment in how can we use a material, straw, which is a byproduct of collecting wheat and other grains. How can we use that as a material that has certain structural properties? There's a whole tradition of using straw bales for building, but they're kind of soft and spongy and not easy to figure out how they function structurally. Here we're using a compressed straw manufactured. These are manufactured in Australia, which are compressed into these 2-inch thick panels. They use them for acoustical panels, like ceiling panels like these. They're light and they're making use of a waste byproduct, right? It's nothing that you would have any other use for other than burning it and producing more carbon. So we're trying to find a way to use these panels structurally and maybe to make other things of different shapes out of this idea. They compress it, they moisten and heat it, and that produces a binding agent from the lignin that is in the material. So they're not bad. We did some testing. We did some burn testing to convince everybody that we weren't building something that was going to go up in flames. Um, and then started building this by using these strips of the material 9 inches wide, stacking them up, and then bolting them together to produce a certain amount of pre-stressing so that the deformation would happen early in the game. And then made corbels out of them, so not just straight up and down walls, but walls that leaned in. Um, Made them into chunks down at Princeton because it was headed up to a property that Paul has upstate. So prefabricated in these pieces that you see here in this model, and then installed it up there. We have screw piles that get screwed into the ground. They're pretty lightweight but effective. And then a wood floor, and then the chunks come in and are put together. You see this? They're happening, and then eventually you get waterproofing on it, insulation in some places, and then thatch. So then the thatch is also prefabricated and then was brought to the site and installed in this. And there's Paul. Um, I'm lucky that Paul loves to build. I'm more of an abstract guy. He's really hands-on and he's really good at it. And oversaw the team that made the panels off-site and then brought them together. And now it's complete and quite cozy inside. And was recently published. Okay, we're in the final stretch here. the infrathin, which is this idea that Marcel Duchamp um, advocated, is a sense of ephemerality, the sense that, an idea, a work of art, a certain kind of event can have an impact while also evaporating in a sense. And this quote that he tries to use to express that. There's a great exhibition. If you have friends or if you get a chance to go to New York right now on his work, which is really an extraordinary gathering of all his work in one place in New York. Um, Back, I think when you were in Houston, this was built. Um, this was ephemeral. It's a recreation of a chapel where frescoes had been stolen and cut apart, but then were recovered by the Menil Museum and turned into a project to place these frescoes temporarily, 15 years, in this chapel made of glass that was supporting, that was recreating the original building. Here are the frescoes, the original chapel. This is what they looked like when they were recovered. The glass is suspended in a kind of spider web of steel rods that is pulled against the roof and the floor and sprung. So there's springs at the ends of the rods that make sure that even if the roof moves, you maintain the tension in the rods. Um, and then the whole thing was taken apart 15 years later. This is during construction. You can see that spider web. And then it was taken apart. So the event of a project, the thinness of a project, all part of this experience. This is a stair that we did with Architecture Research Office, Adam Marinsky and Steve Cassell, which is based on a principle of the Renaissance, and actually even before, of using the interlock between the steps of a stair to allow that to visually cantilever off a wall. Palladio did it. Lots of other architects and masons did it. It actually started out as an idea that masons had in Syria and Greece. Originally, we found some evidence of it in Syria. In this case, and here are some of the examples, in this case, it's suspended off a glass wall. So a little bit magical in its feeling. I've done a couple of these. There's one in Venice. It's great because people don't quite understand how it manages to hold up, but it's the same principle as Palladio's stair in Venice here, or as another stair that I saw one time in Milos in Greece. So the steps are aluminum slabs. That's what you're actually walking on. And the risers are these tubes, and the tubes go through the glass. And the purpose of the glass is to keep the tube from twisting over, because what happens is each of the step above is trying to pull the whole thing over, and the step below is producing a reaction. So what you're having to resist is the torsion going into the wall, which is why it works well, because stone can do that. Stone doesn't like to just cantilever because it cracks, but if you interlock it, then it works. Um, and it held this guy up. Um, the wall at MoMA, which we worked on with Taniguchi, and somebody was telling me they'd worked at KPF at some point. KPF was also associated with this project. This is the wall that I worked on that is very, very thin members. They're 2 inches wide. They span 20 meters. Again, an effort at making something look thinner than possible as a goal there. Same thing happening here with this project, Toledo, the glass pavilion that Yung Ho was talking about, where the vertical structure is very delicate. The stability is actually provided by some steel walls and some braces that you can sort of see there. So I'm not quite sure I remember the part about the building swinging around, but it's a good idea. But then when you're and incredible coordination in trying to get everything to fit together in a very, very thin layer of structure. And then the end result is really looks like the building is held up by the glass, partly because of the optical effect of all the reflections in the glass. So this thinness this disappearing act that I think can be a thrill with structure. It doesn't have to be brawny. It can be so delicate you don't even know it's there. Um, Last project. So this was a really interesting experience. So there's an artist in the US named David Hammonds who is very much the reincarnation of Marcel Duchamp. He has a sensibility that manifests in being quite elusive. He rarely shows up to events. He didn't come to the opening of this. When we worked together on this project, we met maybe 5 or 6 times over the course. He's very conceptual in his approach, but also very playful and ironic in the way that he produces his work. Really brilliant guy. He was, it'll come. He was invited by the director of the Whitney Museum that had just moved downtown into a building designed by Renzo Piano, which I did not work on, where they wanted him to do a show there. But it's not the sort of thing he does. He never really did museum shows. He's done a couple of gallery shows, beautiful ones. But he wants to be in control at the same time that he wants to let things happen. It's quite an interesting practice. Um, he didn't want to do anything in the museum. He didn't say much, but as they were walking around, Adam Weinberg, the director, pointed out that out in front of the museum was the site of this work by this artist, Gordon Matta Clark, who had taken over this pavilion, taken over this warehouse shed, which was on a pier where the ships would dock historically, had been abandoned for a long time, had been taken over actually by the gay community that lived in that neighborhood in Chelsea in the West Village, who used to go there and cruise. And there are all these great photographs from that period. And he went in there and cut these big holes in the floor and the outside wall, turning the whole thing into a kind of cathedral of light. It was a miraculous project in 1975. It lasted only 4 years and then was destroyed in a fire, but it stayed in everybody's head. It was one of those things that either through pictures or through direct experience, people could never forget. And so when Adam Weinberg told Hammonds that, it stayed with him, especially since he had known Gordon Matta Clark a little bit back in those days. And so he came back. Here he is, Hammonds and Adam Weinberg. He came back, and that's the Whitney that this project is in front of, the Renzo Piano Whitney. Came back with this sketch. So Weinberg called me and asked if we could help figure out how feasible this was. So we started from the sketch and started from the principle that what we were going to do is try to realize a pencil drawing in space, and did a series of renderings. Gina Morrow in our office did all these renderings with others that tried to express the ephemeral quality of the structure that we were trying to build, as thin as possible, slightly different geometry because of the way it had to function structurally in the wind, but very much in the same spirit. We had to locate the sculpture, so nobody really knew, actually, if you look back on the sketch, he didn't really know exactly where it was. So Gina actually was able to figure out from documents she got from the city exactly where the building had been, but also the proportions of that building which we were trying to recreate. So how it was divided in 5 parts, how the size and all of that, which we actually had to scale off the photographs. So we came up with this and built what you see here. Each of the members that make this up is 20 centimeters in diameter, and it spans 20 meters. So the span to depth ratio is 1 to 100. They're very thin. So what we wanted to do is make them very thin as we possibly could. And that's achieved by making the ends, the walls of the pipes thicker, so they're a little bit stiffer, and making rigid connections between the verticals and the horizontal, but also bending everything in the opposite direction from how it wants to sag. so that the end result would be dead level and dead vertical. The joints are made to disappear. They all have to be mechanical. You can't weld over the water for environmental reasons. So you can sort of see um, there, you see the two dots. The two dots are these pins that go through that hold the two parts, the beam and the column, together. So the joints are castings. The actual joint there is cast steel, and they're being casted in Brazil. And then the seat between the beam and the stubs that come off the columns are machined. That's what they look like. So they fit together like this with the pins, all in order to get a rigid connection, but also making a connection that totally disappears. And here it is being installed. The goal here was to make something that was as abstract and ephemeral looking as possible, and to make the magic that went into it disappear. The idea that you're bending it, nobody knows any of that. But the fact that it is there, I think, representing this drawing in space that had been mailed to the museum is what we were trying to achieve, and I think succeeded in doing. And with that, I thank you.
The lecture. Thank you very much, Guy. I think actually for me, it's after all these years, this is the first time I listened to you give a talk that really discusses some of the things you care about architecture and engineering. I like to start the other way around, talking about the last project you presented about that joint. So to hide the joint, and only the creators involved would know, is something always is very intriguing for me. I could think of two buildings would share a similar story. One is probably more, it's better known, put it that way. Actually, it's Frank Lloyd Wright, the Roby House in Chicago, and with a huge cantilevered roof at the end, and I think the construction team suggested a way of building it, and Wright wouldn't agree. It was built in a way with a very thick steel plate. So structurally speaking, made very little sense, but that's what they did. And then the workman or the job captain argued, no, that's not the good way. Nobody knows what you're doing. You do the right way. And the answer is, I would know, right? So for that reason, he did that invisible, irrational design. And then the other one, which I don't know really why at all, is Shinohara's. One of the houses are more than one. It always let the column goes into a very abstract ceiling and then make the structural joint disappear. And then that joint was very carefully designed and then not for people to see. So I guess you must understand after doing that project why Shinohara or Wright probably is not the right story here. Why Shinohara would hide a very elaborate joint. Do you have any reflection on that?
Um, I mean, I think that feeling, the the I mean, the Wittgenstein quote has a lot to do with that. I think that there's a certain okay. I think that there's a certain way of operating in the world where you feel that is an important, you do things you do things well and then you hide them. And I think that it's just a choice that some people make because of the way they want to be in the world, you know. Um, I had something else I wanted to think, and I know I forgot it. Um, yeah, it'll come back to me. It's it's not a common thing these days, right?
Yeah.
I think we want to show everything. We want to display everything. It's a choice you make, right? And you can make the choice of also doing things badly and then hiding them as well. Everybody has to live with whatever that decision is that they make. Um, and the other thing will come back to me.
Okay. It's really great pleasure to be invited here. Sorry for late, but actually last year I invited Guy to make a speech in Shanghai. So I start from the Jubilee shell structure. Maybe that's the practical part of practice. Maybe I'm missing the theoretical and philosophy and the history of the architecture engineering. But I think Guy is one of the most greatest structure engineer in the whole world, from my understanding, because so many great architects working with him over the years. Especially, I visit Stephen Hall's office many times and see a lot of projects. You working in Houston project, for example, I can see a lot of the process, what's happening. You're collaborating with the architect. Actually, it's not. It looks like just a structure engineer. Actually, have a great understanding from artistic perspective, from the architecture perspective. It's not like a post-rational process. As structure engineer, actually, you engage a lot to the conceptual design, and also I think it's difficult to figure out who is architect, who is structure engineer. We can see a lot of structure concepts actually hidden in the architecture as a holistic artifact. So that is maybe the special impression from me. My question goes to actually you're collaborating with so many great architects like some like Renzo Piano is very like great understanding both architecture and structure engineer, but the other like Stephen Hall, who is very uh, very artistic actually from a lot of drawings. Actually, the drawings is not some structure logical things. It's not tectonics, but actually, I would like to ask like also Sana, who is super light, like the glass curtain wall you mentioned, like the structure system to support the whole ceiling, right? So when you're collaborating with them, I think because sometimes the architect is very like rational. Maybe it's like some very phenomenon experience can guide them to make some like just sketches, to describe architecture in different ways, to present the architecture in different ways. From your lecture, it's not like a structural engineer to present a project. Actually, you present like architect. So how in the process, I mean, when you're working with these great architect, from your perspective to be a structure engineer, how you're working with them, the process to maybe why they like you so much and to solve the problems like in a certain way. It's not your style, actually. They have their own style, but actually they solve in a very dramatic ways. And secondly, I think as you are a professor in Princeton, I think Princeton is also special. The architecture and the structure engineer, they integrate quite well, including this leader and including Sigrid. I know Sigrid very well. She actually also talking a lot about you. You're leading the whole team there. So I also want to know how do you teach in Princeton recent years in the architecture school? I mean, uh, this kind of technology or this kind of engineer knowledge how to engage into the teaching pedagogy process. Two questions.
So I think the reason why I try to use the film analogy partly is because I don't think we have very good language to talk about these things. Um, Frank Lloyd Wright wasn't about to
share the spotlight with anybody else. And he represents a certain lineage of architects, Corb, etc., who model themselves. Corb modeled himself after Picasso. You know, the role of this almost as representative of God, this Promethean figure who comes along and has this tremendous capacity to invent form and to bring it into the world. Frank Gehry is a great example of that as well. So that's the image that we have of how the best architecture is made. You mentioned Sana. Over the years, she's become more specific about the way that she talks about the architecture, but it's always seemed to me as if there is an element of magic in the way that she works, and that for those sitting around the table during that process, you really just react to the representation and try to internalize that and respond to it in as sophisticated a way as she produces it. If you think about film, inevitably you start with a script, and there's a project, and there's a story that's being told, and then everyone operates from that script and is maybe interpreting it in different ways, and they can have huge fights, like the story of Sergio Leone and Ennio Morricone about the music in that Clint Eastwood movie. Khan and Commandant had a big fight. They had a lot of fights about the windows at the end of the galleries, whether they were going to be parallel or they were going to taper. People get obsessed in the same way that an actor gets obsessed about his interpretation of his role, because you start from the script. And I think that's maybe a way to think about these situations that you're describing. Stephen Paul shows up with a watercolor, right? Sometimes we end up building the watercolor. We did a stair in Iowa that looks exactly like his watercolor because it was such a magical idea. Sometimes it's a bad idea and everybody talks about it and eventually it becomes something completely different. Or sometimes you just absorb the script, like the glass pavilions in Nelson Atkins, and you find ways in order to enhance it. We came up with the fluttering tees. There are all these different ideas that have become part of the legend. I think we need to find a better vocabulary to describe all this. And that's why I keep coming back to film, because I think it helps us realize that there are all these different creative acts that, if they're managed skillfully, I'll be quiet after this, but think about the great offices. I.M. Pei's office, Frank Gehry's office, to some extent, Norman Foster, Renzo's office. These are orchestras where they're all operating from a score that Renzo will have articulated in diagrams and sketches. But everybody understands it and knows how to play their instrument extremely well. How you produce that is fundamental, I think. And maybe that's a way of answering your question.
There's a second question. Princeton.
Oh, Princeton.
Yeah, teaching there.
Well, I alluded to this in our earlier conversation. I think we're at a moment in architectural education where we are, I use the word tired. I don't think that we are operating at quite the level of energy that we could be. Not sure if this is just the experience that I have in the US or if it's true elsewhere, but we do function from a number of ideas about what we're about that are getting a little old. The relationship between theory and practice, the relationship between technology and form. We see a lot of the activities in a school of architecture as being subservient to the studio. Maybe that's inevitable, but maybe it's not. Maybe, again, back to my film analogy, maybe we need to create an environment where somebody can come into the schools thinking they want to be one thing and decide that they're going to be something else, like Ito becoming an architect instead of an engineer, or Sasaki the other way, you can go into a music school, musical academy, thinking you're going to be the world's greatest pianist. And then you discover all these other pianists, and then you realize that your fate is actually to be a composer, or a conductor. So how can we create an environment where people discover their path and they don't all have to grow up and be Liz Stiller? It's or Frank Gehry or Yung Ho Chang. It's there are other options out there that can be creative and satisfying. We need to recognize that, we need our own version of Oscars or something. We need to find the right words in which we can talk about it, which I try to do. It's not easy. So I mean, it's also an opportunity. That's why we're here together, because we're going to reinvent education, right?
Maybe I can try to reinvigorate this through nostalgia. So 3 ways I'm going to start this conversation, because I couldn't figure out which one to go first. One is the project that you showed with the glass at the ARO. I joined the office at the opening of that project. So I actually went to the opening, and I remember the conversation we had. No, not that formal opening. And anyway, it wasn't. It was open. Obama is 10 years later. So, but anyway, I remember at my thesis reviews, you may not remember, but after that, you pulled me aside and said, I know just the office that you should work in. And then that's where I went. But so that's the reason why I want to start that is because the second one that I'm starting is that all the way from Asia, from Singapore, being the first one in Princeton, I was told that they haven't had anyone from Southeast Asia for the last 15 years. I don't know if it's true. I had knew about the reputation of a school that prioritizes history theory and the critical and the Colominas and Wigleys and so on, that I make a very big effort to make sure that I will only take history theory courses when I get there. So I went to make a case to the director of the school that I don't want to take any structures or construction or building technology courses because I want to focus on theory. What happened in the late 90s was when I got there was your fantastic lectures. There was Antoine Picong's lectures. There was Carlos Wallenrath, who spent every course looking at all of Kahn's drawings on bricks. And then there was Young's, and then there was Gretling discussing, the form of the blob. And it struck me, and I want to kind of reflect and also ask the first question about the theme of rivals. It struck me that in many schools, going back to current debates, is that the split between the more humanistic and the technology, it's, I think, worse than ever. The chasm is, I don't know if that's the case or not, but that wasn't the Princeton I discovered when I was there, because I thought that we were going to discuss gender in Beatrice Colomina's course, but we ended up spending half the semester on Mies van der Rohe's columns. And so anyway, what I'm saying is that my whole first year was about structure. And it occurred to me as we were talking about the film, and that also planted a seed because I took many film courses at Princeton, which then led to my film course here now. And we can talk more about that. Was the fact that the divide was so blurred, there wasn't really a divide at all. That historians were talking about technology like they understand technology, and technologists were, I don't think you want to be called technologists, but engineers and those whose primary work was construction and technology were very sensitive and conscious of history. And I think that was very invigorating, especially for someone entering that. So I would like to know where the team of rivals and how that is doing in this in the current climate. How could we maintain that in a kind of sustain that kind of conversation, because I would totally love to do that, to sort of cultivate the kind of rivalry we're talking about.
I mean, one of the things that we're going to talk about in the next 2 days is the education of architects and engineers together. And there are great examples in Europe. And we've had a few talks on Zoom with some of those folks that we've been part of. You know, right now I'm sitting here, I'm an American, and my government is a rival. And we have all these different rivalries around us, right? And so to some extent, intellectually, you know, we don't always talk about these things in architecture school, but they relate to architecture school. You know, one of the reasons that I wanted to do these workshops on engineering and architecture, because I think in the abstract, that's really important. But also because I wanted, you know, you invited me to come here. I wanted to find a challenging topic where we could spark a conversation about a different way of educating architects and engineers together in a country led by engineers, right? And in a country where there is, well, not maybe, but also in a moment where we are all struggling with technologies. You know, we talk with each other a lot about AI. We are in this rivalry about different ways of approaching AI. We are in this rivalry about the industrial backbone that, you know, I was reading an article today about chips being fabricated in China that would create an independence from NVIDIA and so on. We're in this moment of history, which is energizing, right? I mean, we need to be thinking about that. And the culture of design that is embedded in certain aspects of the culture of Silicon Valley is a culture that we should have some degree of control over. You know, when Steve Jobs, you know, I could do a whole lecture about Steve Jobs and design, right? When Steve Jobs decided to start doing stores, he brought together a team of rivals, of engineers, of architects, but he was in control. He was the orchestrator, and he made them do amazing stuff. They invented all kinds of new ways of dealing with glass. They built a whole new factory in Germany to make the glass, et cetera. Those are projects like the iPhone that were driven by a sensibility that is totally familiar to us, right? When you do a project where you want to make everything as thin as possible and you want to make all the joints disappear, you're acting in the same spirit. You know, this phone, which is sitting over there, this phone, I can't open it up and look at the joints, right? But they're amazing. So I think rivalry is a good example of
I was thinking more radical, actually, like an anthropologist, or even more radical than just because the team of rivals we're talking about are all consultants, you know, they are kind of related.
Well, consultant's a dirty word.
Oh, okay.
I think it is part of a culture that does not want this rivalry to take place. One of the people that came to talk to our group on Zoom is an anthropologist in Mexico, Pablo Landa, who is one of the great curators of our time. He's fantastic. He's in the middle of organizing exhibitions and so on, capturing the energy of what's happening currently in Mexico.
Actually, my second question or reflection is a more technical one, because in this part of the world, whenever there's something major like 9/11, there's a serious investigation of the building regulations, which invariably, some of us here may be old enough to witness a few, and invariably they ended up opposite to ephemeral. They end up oversizing things. So I was just curious what the discourse and direction is in the context, say post 9/11 and so on, in terms of how, because what you show in the MoMA in the edition, the thinning and the infra thinning, that's is that just a one-off, or did it actually affect at all attitude towards structural dimensioning, etc.?
You're asking what effect 9/11 had, for example,
Yeah,
or any disaster.
in terms of structure, like
Different, well, maybe an indirect way of answering the question. There's been a change in attitude about how to deal with flooding, which is, typhoons and so on, which is to try to learn from nature ways in which that can contribute. So I think it's not always the hard approach. Questions from?
Yeah, I'm conscious of time, but let's maybe give the audience a chance to ask a question. Thomas.
Jean, in your bio, it say that you work for Isamu Noguchi as a draftsman, and one of my first imaginations to think about Isamu working for Brancusi when he got the Guggenheim Fellow as a 23, moved to Paris, worked for a Romanian sculptor, and what he got out of that half a year was he learned how to make base. So he came back, so you could see that his work start to take this major change, so that you could sense that somewhat in flight and such. I was curious when you did your draftsmanships in the studio in Long Island. Was it Long Island City? What are the things that you picked up, the nuance in the studio and that legacy of Noguchi that time, in a way to think about an art and science together?
I'll try to keep it short. So Isamu is the reason I became an engineer. So he was friends with my mother, and I was trying to figure out in college what I should do. I love literature, I still do, and love to write. And he somehow decided, no, you need to become an engineer. So he told her that I should come and work in the studio because they had just bought the building together with Bucky Fuller. And so the idea that I would somehow be influenced by Bucky and led into that world. We had many, many conversations. He was extremely cultured, read voraciously, was involved in so many different worlds. It was at a moment where being an artist meant doing one thing, like Mark Rothko. And Noguchi would do many things. And some people were critical of that, but he was just voracious that way. The story about Brancusi is a good one. He begged Brancusi to work in the studio, and Brancusi told him to go to hell several times, and he kept trying. And then finally, Brancusi said, "Okay, you can sweep the floors." And one of the things that he said he learned from Brancusi, which was very important to him, was to clean the studio at the end of every day. So every day, at the end of the day, Brancusi would put all his tools away. And Isamu said that was the one thing he learned from Brancusi that was more important than anything else. He was voracious. He was generous. He had the kind of creativity we're talking about, that sort of Steve Jobs sort of creativity in everything he did. He did it with an incredible intensity that was infectious. Yeah. No, I mean, if it weren't for him, I wouldn't be an engineer.
Because later in 2009, you were at the American Academy in Rome as the first engineer residence ever in history. And you probably saw a lot of studio. Were they as clean as you imagine?
No, but that doesn't mean they weren't productive. That's where I met Clover Lee.
David.
Yeah.
You brought in Fuller.
There he is.
Well, I mean, we all miss that era that engineering is engineer and architects work together, or engineer slash architect can raise something, brings up new concept to construct a new world. Yeah, that kind of era. Of course, we are kind of losing that kind of ambition somehow. I would say in the recent years. Would you kind of elaborate a little bit on your vision and for the future, and maybe with the digital fabrication and AI, would you think there's a new chance for us or for engineer particularly to rethink about constructing a new world with engineering? Yeah, like Buckminster Fuller is the only one who inspires chemists to won the Nobel Prize, right? The only chance, only time. Yeah.
I'm not a fan, but I have two words: Elon Musk. Right? I think he's a monster in many ways, but he is taking us to a different planet, right? There is an energy there that somehow has produced a level of productivity in other people. I don't think he's very different than Bucky, but he does get Bucky does get other people to do the work, and the work that they do is pretty extraordinary, you know, convincing government here to build the Tesla plants, propagating Teslas everywhere, maybe producing the kind of competitive energy that has, talk about rivalry. Why do we have such incredible electric cars here in China? Maybe it had something to do with the energy that he brought into the space. Um, I don't think we're lacking those kinds of crazy people. I think we just don't have the.
He was not trained as an engineer, right? He
Oh,
was a
well, who
wow. You
cares?
can say
I mean,
that's
neither
true.
neither was Steve Jobs. I mean, they
Yes.
dropped. I mean, most of these guys dropped out of college. They weren't trained as anything. I work with Shasha. She's a really good engineer. If it weren't for her, I wouldn't be able to do any of this stuff because I'm not that good at it. So I think there are collaborations that are essential in getting things done and ambition. I mean, there's certain times where she's pulling her hair out thinking, oh my God, why are we doing this? You know,
That is a constant conversation I have with Guy because he always has the wildest
and then
imagination and
we get it done, right?
yeah, then I pull my hair out and then we we make it happen. But
But
yeah,
it's still there,
mean,
right?
it's turning
grows
gray,
back.
but I'm trying to keep it. Yeah.
Oh, yeah.
No, yeah. Actually, I wanted to share a film that influenced me a lot with Guy, probably with everyone here. It's about a crazy director. I forgot his name, but I always remember the name of the movie. A lot of you may have seen it. It's a Fitzgerald. What's the name? Yeah, Werner Herzog, right? No. He made the also the movie itself. If you haven't seen it or you don't know the story behind, it's something actually worth knowing. And so the story is in Latin America somewhere with this amazing landscape. It's about two rivers merging together, and there's a hill in the middle. So the way to travel, it always has to go around that middle part. It's sort of an island in the river. And then, however, the protagonist in the movie, I think actually is more, Herzog himself, really say, no, that's not a way to travel. That's too far. We should move the boat, cross the mountain, and get to the other side instead of go around it. And then what he did was that to make it happen, to build the boat, to actually go down that river that exists, the river exists in reality, and really move the boat with all these workers to the other side and then put it in the other river. By doing so, unfortunately, it's very tragic. Quite a few workers died through this process. But of course, this is not what I'm going to talk about. But the fact is, make a fiction an idea, not just to show how it looks, but turn it into a reality. So that's something actually, think about it, that's what we do as architects. So somehow, it just, you were talking about films. I thought that's a film. If you haven't watched it, do it tonight after going home and find it on the internet. Yeah. Yeah, Fitzgerald. It's what's the name again? Werner Herzog. Yeah.
The guy. All his movies are amazing.
Yeah.
All right, thank you for joining us, everyone. On a lovely note, let's give Guy a round of applause again and our panelists.